Hi, I'm Diane Galbraith, President of AWA, and welcome back to our monthly presentation, which we are now doing on YouTube instead of meeting in person. Before we go to our presenter for today, there's a couple of things I want to go over. You get a weekly bulletin, and we're going to be attaching a lot of things in that so that you don't get a multiple of emails all week. And then once a month, you will get the newsletter. The bulletin, we've gotten a lot of positive feedback. You can advertise things for free, for sale, if you need help. So you're getting those. If you want to put anything in it, please do. The newsletter will be coming out about the third or the fourth week of the month, and we'll have more details in that, so look for that as well. One of the new projects is the little free libraries, and you've already received information on that. If you have any more questions, there's people listed in there that you need to contact, and we're excited about that project. I also want to ask you to please support our sponsors, which we have quite a few of them. Woodworker Supply, BMC, TJ Hardware, Exotic Woods, Rugby, Precision Sharpening, and Grizzly Storage. We've also added one more, which is Hunter Bauer, which is on Manal.
I'm Aaron Hall. I'm a longtime member of the Albuquerque Woodworkers Association, and today we're going to talk about woodworking machinery, how to evaluate it, if you're buying a piece of equipment, how to adjust it, and how to get the most from it. So why should you listen to what I have to say? There's really, I guess, two reasons. One is I've been building furniture for about 20 years, and I've built a little bit of furniture, not a lot. The other is I've been rebuilding woodworking machinery for a little longer than that. And all the machines pictured here, you're going to see in the video today. They're in various states of repair here, kind of where I got them. So the bottom line here, and really what I'm going to try to tell the story of in this talk, is that joiners, planers, bandsaws, and table saws work together. And we want to think about how to use them together when we're putting together a workshop or adding a machine to a workshop. Tuning them up is usually straightforward. Most of these machines are pretty rugged, and they're relatively simple machines that can be tuned up with really simple tools usually. You don't need to spend a lot of money on the tools to tune them up. You may need to find some help on some information on how to do it. The other thing I want to talk about, and we're going to talk about it as we go through, is that safety gear and effective strategies for working with the machines make you more effective, and they make you more successful with your projects. And what I mean there, and really we'll talk about it hopefully before we're done today, is a process for getting straight and square material out of your joiner and your planer when you're done, because every project, the foundation of every project, is straight and square lumber. With that, let's talk about how joiners work. So joiners do really one thing, and they do one thing very, very well. They make one face of a board flat, and they make one edge square to that flat face. So they give you one edge that's straight and square. And in doing that, they create the reference surfaces for everything else you will do with the furniture making or the project you're doing with that lumber. Instead of talking about it with the slides, let's go over to the machine. So every board starts out as a piece of rough lumber. Now, this is a board that I've cut to length, and I've ripped close to the finished width I want it to be. But it has not been planed, it has not been jointed. And when I say it makes one face, the joiner makes one face flat, and that's the first thing you do with a joiner. You can make one face flat. What I mean is the broader face of the board flat and one edge straight, so like this, and the two of them square to each other. Can you see that? That's the critical thing a joiner does, and it's really the only thing a joiner does for you. It may seem like investing in a machine that only does this is a little silly, But the truth is, a joiner does this better than anything else. It does it better than a planer can do. Your planer works better if you start by putting your boards across a joiner. And joiner kind of becomes indispensable because doing this by hand becomes very challenging. The way a joiner works is it removes the high spots on a piece of lumber. So this is just a piece of scrap, but you can see the idea here. If this is sitting on the table, as it's passed across the, I'll try to do this so we can see it, as it's passed across the knives of the joiner, the outfeed table is slightly higher than the infeed table. And as a result, those knives are going to cut whatever's hanging below the outfeed table as the board comes across. And that's going to remove all the high spots on the bottom of the board and eventually make this surface flat. Once that's done, you're going to go in here against the fence, use the fence as a reference for 90 degrees, and do the same process on this edge. Couple of things about a joiner and how they work. If the outfeed table, it's critical that the outfeed table is at the same height as the high point of the knives. The tangent, the circle that the knives make, you should be able to draw a tangent line from the top of the outfeed table right out to the top of the knife. If you're not, if that outfeed table is either high compared to the knife circle or low compared to the knife circle, you're going to joint funny. Your board is not going to be cutting in the geometry the machine's supposed to cut. You'll end up getting kind of strange tapers in a board. You get some chatter, other things. The joiner won't perform the way you expect it to. And so one of the critical things you're going to do when you adjust a joiner is, and when you set knives in a joiner, is get them set in reference to the outfeed table. And the outfeed table really is the reference surface. It's one of two reference surfaces for the joiner itself. We'll talk about safety with the joiner in a minute. So really the way a joiner works is you have a cutter head, you have that outfeed table here and the infeed table over here. The infeed table is where all the adjustment for thickness of cut happens. You lower it down to take a thicker cut, you raise it to take a thinner cut. What I have here is the old cutter head from that joiner, and I wanted to show how a cutter head works. And I have all the pieces of the cutter head sitting out. This is the actual cutter head. The bearings would sit back here. The knives and the thrust bars are going to sit in here. These are what are called the thrust bars. This holds the knife in the cutter head. This is how a typical joiner, a typical straight knife joiner is built. What you have is just a wedge. You see this is kind of a wedge-shaped piece of metal with a whole bunch of screws in it. It's going to sit in here. And I don't know if you can see that geometry on the end here. It's going to sit in here. A lot of joiners, and this one does, have what are called jack screws. And that's what these are. This is just a screw with a little piece of metal on it. When you give that screw a spin, the piece of metal comes up and down. That's what these holes are for. The jack screws sit here right under the blade, and when you're setting this machine up, they allow you to raise the blade. It's relatively easy to take a board and push that blade back down, but trying to lift up, so this is one of the knives. I have tape over it because these are like razors. Sharp, newly sharpened joiner knives are very dangerous, and one of the best ways to protect yourself is to put some tape over it. Of course, that'll have to come off when it's time to install it. But the knife's going to sit in here like this, and as you're setting the knife height, you're just going to give the jack screws a twist to raise that knife up, put a board on it, and loosen the jack screws and push it down, and then the bolts back here all get tightened to clamp that blade in place, if that makes sense. We turn this a little more, is that what you want? Okay. So I hope you can see the geometry here. I'm not going to pull the tape off because I don't want to get cut. Anyway, some planers have jack screws, some don't. Some planers have a different mechanism for mounting the knives where you're really don't have to move knives up and down. You simply dispose of them and replace them. But most machines have knives that you're going to sharpen, and you're going to have to reset them. The only tools you have to do this are a wrench that fits your thrust bars, something to turn your jack screws with, and you need a board that's a straight edge to check and see if you're lined up with your table. And you need a dial indicator with a stand. Something like this is all you need, a dial indicator that'll read 1/1000th of an inch. And the procedure here and the goal when you're setting up a joiner, this one, it's got 4 knives. Every one of those knives needs to be at the same height with respect to the table, to the spinning cutter head here. If one knife is sticking out a lot farther than the others, it does all the cutting. And you get a big scallop where it cuts. It does all the work. It gets dull fast, things chatter. You have to get all the knives at the same height. You also want to not have your knives like this, exaggerated, skewed with respect to the cutter head. You don't want one end high, one end low. We want those knives in there straight. And the way we're going to do this is, and you can see it, I've got 3 Sharpie marks on here, 3 lines that I've just took a Sharpie and rotated the cutter head when it was in the machine and drew a line all the way around. This lets me take a measurement with the dial indicator at the same point on each knife. So I'm not trying to guess whether number 3 is high when I'm measuring it here with respect to number 4 that I'm measuring down here. I'm measuring in the same place. I'm going to measure in 3 locations. If it's the same in these 3 places, it's as close as it's going to get all the way across. I'm going to set this, since the cutter head's out of the machine, I'll show you. What I'm going to do is I would set this over here on the outfeed table and measure with respect to the outfeed table. And we'll set all the knives close, and then we go in and with the knife installed, and with the tape off, of course, just gently roll that indicator point right over the, so we move the cutter head to take the measurement. Unfortunately, you can't see this because it's taken apart. But we would move the cutter head to take the measurement and just go right past that indicator until we see where the high spot is and try to get them all the same, all the way around. It's going to take some time. It's going to take a little bit of patience, but it's not difficult to do. Once all the knives are set to the same height all the way around, then we're going to go, and there should be almost every joiner is going to have some kind of a mechanism for raising and lowering the outfeed table. This one has a wheel back here and a clamp on that wheel. So we would loosen the stop and give the wheel a spin. We'd bring the outfeed table up and down until we get it tangent to the height of the knives. We're not going to try to reference the knives to the table. We just want them all the same when we put them in the cutter head. So the easiest way to set an outfeed table to a newly installed set of knives is to put a board on the outfeed table, have the cutter head where it can be rolled, and slowly lower that outfeed table, manually roll the cutter head until it just grabs the board and pulls it. Okay, and it'll just grab that board and pull it forward. We would never do any of this with the power on, of course. We just roll it by hand, and you'll be able to tell when you've lined up and caught it. And then you're done. It's there. You want to check, especially for a wide machine like this, all the way across. Make sure you don't have something where the knife is much higher than the outfeed table on one side or the other. If you do, that needs to be corrected. All the knives need to be parallel to this surface. But once you do that, your joiner is set up. On a day-to-day basis, you have to check a joiner. You should probably get in the habit of checking it every time you use it. I keep a small machinist square that's a fixed blade square near my joiner. And I have gotten in the habit of checking my fence before I joint boards every time. You just come in here on the outfeed table and check to see if it's square. And if you look at this one, it's not quite square. Joiner fences are notorious for not being quite square. So we'd adjust that. We just loosen up the clamp here and adjust it a little bit before we're ready to work. But every time we work, we're going to check that before we start. And in fact, check it periodically as you're using the machine. If you're out here for an hour or two joining a lot of boards, this is a critical thing to check. And you can see that one's not quite square. I've never worked with a joiner where the fence didn't get out of square on a regular basis. Fortunately, they're easy to adjust and put them back to square. So you check this every time, and while you're working, we'll talk about it later, we actually check to see that our boards are square. So a little bit of joiner safety. Joiners are very dangerous machines. The cutter head is out here and it's exposed where you can get into it. If you get into it, this thing will cut hardwood lumber, it will cut you. No questions asked. And joiner can cause a very severe injury. So the first order of business with a joiner, first order of business is hearing protection and eye protection, always. But then no long sleeves, no wristwatches, nothing that can get caught in this joiner head and pull a hand in, okay? Always have a guard on the joiner. We see a lot of people use table saws without guards. I don't have a big personal objection to that. I have a guard on my table saw. A joiner I would never operate without a guard, period. And we'll talk a little more about that. The next thing, so you always have a guard, but recognize as the board comes across, the guard swings out of the way by necessity, right? The board's going to push it out of the way. So, push blocks. These are push blocks intended for a joiner. I think they might have cost me $15, and I've had them for 16 or 17 years. They are worth every penny that I spent on them. They have a little hook back here. They're angled, so as I run a board across, I can just get in here and feed it. If you don't have a set of these, I would highly recommend spending the $15 or $20 to get them. If you're going to use a joiner, you simply shouldn't use a joiner without them. Certainly for this operation. Once you're doing this, and you're up here, it's a little different. You can't really use these blocks effectively in here. Some people can, I find I can't. You're going to feed this with your hands, but you want to avoid getting in the habit of running your fingers like this. Take your hand out and grab the other side as it comes over, okay? And recognize that there's a minimum thickness of board, minimum width, that below which you really shouldn't be running across a joiner. Rough it in wider and rip it down with a table saw. Take a different approach. But you want to always keep your fingers and any loose clothing away from that cutter head. The other thing about a joiner, and it's easy for it to go unnoticed, no loose knots. And what I mean by loose knots are things like this, where you got a piece, and I saved this just for this talk. See how that knot kind of moves around? This is a disaster waiting to happen in a joiner or a planer. And what needs to happen is this needs to be cut away, cut out of the wood before it gets put across the joiner, period. You never put something like this across the joiner. The reason is the vibrations of the machine and the cutting action are going to cause that to fall out. It's going to go down in between the cutters, and now you've significantly overfed this machine. And best case, that thing's going to chatter and kick and jump back at you. It may just explode, shatter, start throwing pieces out. It might break a knife. It can cause a lot of problems. The joiner's not meant to cut through that in one shot all the way through, okay? So cut that out with the radial arm saw or with a jigsaw or something. This happened to be in the middle of a 10-foot long piece of oak that was pretty much clear otherwise. Well, it wasn't a 10-foot long board. It was two 5-foot boards, okay? That can't go across the joiner. It can't go through the planer. So just recognize that when you're roughing in lumber. Other examples of things to be avoided. You might get away with joining something like this. There's a good chance a big chunk of this is going to come out on the joiner. This is a piece I cut out. Ends are gone. There was a nice piece of wood over here that I kept. But a big knot like that, it's worth getting rid of. You're not going to use it in a piece of furniture most likely not going to use it anyway. Stuff like this, where you've got a lot of wind shake or crack in a board, you're not going to use this anyway. This is also a problem waiting to happen in a joiner or a planer. And so, again, before the lumber goes across the machine, you cut this out. Okay. In fact, the first step for roughing in a board is to cut the lumber down to the minimum practical size before you start jointing. Cut your rough lumber down. We'll talk about how to do that. A radial arm saw is a great way to cut rough lumber. A table saw is not a good way to cross-cut or rip rough lumber. In fact, you can't do it safely on a table saw. Bandsaw can rip rough lumber. A circular saw, a handheld saber saw, a simple hand saw can cross-cut rough lumber for you. But you want to cross-cut it. And then you want to rip it, especially if you've got a lot of warp. This was a great piece to save because it illustrates why you'd want to rip a piece of rough lumber. I put 2 lines across this, and you can see this oak board was a good 5/4. But you're going to get about a 1/2 inch out of that if you try to save the whole width. There's no way around it when it's got this kind of warp in it. But if you simply rip it down to 4 or 5 inches, there's a couple of beautiful, nice, thick 4-inch boards here. If you have a lot of twist at one end of a board, which often happens around a knot, cut that out. So that thing lays flat on the joiner table and you're not trying to get through that. Okay, a couple other things. I said a joiner is good at one thing. It's good at making one face flat and one face square to it. You will see, and I have some pictures in the slides, of old joiner manuals. They're probably 40 or so years old, that talk about tapering with a joiner. You can taper things with a joiner. You can start your board here and cut from here to there and do this repeatedly and make a tapered board. There are much better ways. Okay? A sled in a planer is potentially a safer way. Resawing that is a safer way. You will see people and a lot of joiner manufacturers, most joiners, and this one does, has what's called a rabbiting groove. Okay? What this is for, the idea with a rabbiting groove is that you can use a joiner to put a rabbet on a board by jointing off the end of the cutter head. And now I'm going to cut out a rabbet over here. Well, to do that, a lot of joiners will have a piece that sits where the fence is, a little arm that comes out and around to support a wider board, and where the guard is. You take the guard off. So the guard wouldn't be here, and now we're running boards over here with the fence up close and we're just using the end of the cutter head. Yeah, get a router. Okay? I have seen joiner manuals where they talk about using a joiner to cut out a section like this and leave the end and the end by, again, start here, go part way, lower the outfeed table, a bandsaw, a jigsaw. There's better options for things like this. Just because you can do something with a machine doesn't mean you should. In my opinion, most of those manuals that show all these funny operations you can do with a joiner is a sales department that got overzealous. Okay? There's nothing safe about it. It puts you at risk, and there are almost always better options. So if you're doing something other than making one face flat and one face square with your joiner, you should look around for another option. Okay? Joiners for one thing. You want it to do that well. Straight knives, just to talk a little bit about cutting edges on a joiner. Straight knives work very, very well. Okay? It's important that they are sharp. If a joiner is getting really loud when you run it, very often that's because the knives are dull. It'll make a lot more noise when the knives are dull. As long as the knives are sharp and well adjusted, the machine will work very, very well. Part of the reason for that is you can control the rate at which the board goes across. So you can control the feed rate, which means you can make lots of little cuts or you can feed very aggressively. You can get, and I have, carbide cutter heads for joiners. In fact, you can retrofit them to most joiners. They do offer a few advantages. The primary advantage is these carbide cutting heads, because of their geometry, virtually eliminate tear out. And if you work with figured lumber or with lumber that's prone to tear out, they can be a great investment because you really can't fix tear out. It's hard to sand it out. It's hard to get rid of it. And if you introduce it at the first step of your project, it's with you all the way through finishing and through looking at that piece on the shelf. They're very, very convenient once they're installed. All you have to do is rotate or replace these carbides, and the carbides last for years and years. So there's a big advantage to them. What you will find is they also consume more horsepower to operate, because instead of one knife taking a cut, the cutter head rotating freely, and the next knife taking the cut, there's a continuous cut happening all the way around. There's always a tooth engaged, which means the motor's consuming a little more power. In practice, you probably never notice it. Worst case, you might have to upsize a circuit breaker or something, but they're a fantastic option if you're looking to upgrade a joiner. I have some pictures in the slides of some really old cutter head styles, what are called clamshell cutter heads, where you're bolting on the knives essentially with some clamps. These are to be avoided, simply because they don't tend to hold knives as securely. One of the key things with this design for a cutter head is that once this is installed, if things try to come out, things try to slip, the wedge is trying to slip out and it gets tighter. Okay? This whole wedged assembly gets tighter, which means that if it's properly installed, it's very unusual for this to shed a knife. An older clamshell style machine, and by older I mean like 1930s, 1940s, those can be pretty dangerous, and it's easy to find examples online of shattered cutter heads and knives where those things have come apart. Sometimes great big machines with clamshell cutter heads can go very inexpensively. The thing to recognize with those is that they may never have been designed to operate at the cutter head speeds that a modern machine's designed at. Carbide head, even a straight knife head like that, is designed to be rotating at a few thousand RPMs. It's got big sealed ball bearings, not old babbited bearings. An older machine that's not ball bearing driven will probably never be able to perform the way a newer machine will, simply because you can't get the speeds out of it. So there's a few things to think about there. There are a lot of great options for joiners out there. The thing that matters the most is the width of the machine. This happens to be a 16-inch wide joiner. It can joint the full face of a 16-inch wide board. Rarely have to do that, but this is the widest board I can work with in this shop, and this machine defines it. Okay? I can glue up to much wider, but I'm never going to work with a single board that's wider than 16 inches and expect it to be straight and flat. Okay? There might be some exceptions to that if you've got a great big slab, but that's in practice, this is a limiting capability for the whole workshop. We're going to talk about planers here with the slides because it's very hard to see inside a planer, and I'm not going to pull guards off mine to do it. We will show the planer. When a board comes off the joiner, one face is straight, one edge is square to that face. And I don't have this one marked for the reference edge, but it's a really good idea to take a pencil and mark this edge in this corner so you know where it is and it follows you all the way through to the table saw and the rest of the project. The way a planer works, board's going to feed in with the reference face down, the face the joiner has made. And the planer, again, it's only going to do one thing. And what it's going to do is it's going to make this face straight and flat and parallel to this face. That's all a planer does. It just makes the opposite face parallel and flat, and it gets everything the same thickness. You could turn this board over and make the face flat on the joiner, but it will not be parallel to the reference face. You have to go through a planer to do that. And the way a planer accomplishes that, the reference surface in the planer is the planer table, which generally moves up and down to set thickness. The knives are spinning above the table in this case, so they're coming in here and cutting. The cutter head is typically essentially the same as the cutter head and the joiner. The knives are installed the same way. You use the same basic approach to set them up. You want them all nice and at the same height for the same reasons. You want them parallel to the axis of the machine so that you can bring that table in and set it. The planer has a few more things going on. You've got an infeed roller, which is going to take that board, it's going to grab it, and it's going to push it through the machine. It's going to push it through the cutter head. There's what's called a chip breaker in there. Usually there's a table roller directly opposite the infeed roller, so it's not just pushing against the table, helps the board feed. The chip breaker does exactly that. It takes that cutting that's coming off and breaks it. It holds the board down, tends to reduce tear out. Behind that, you have what's called a pressure bar, and it's holding the outfeed side down while the cutter head is doing its work here. Then there's an outfeed roller that's going to grab it on the other side and take it out. Usually the infeed and outfeed roller are driven and the cutter head is driven. So a good reference face on your board is critical to your planer operating. If you get this board across the joiner and you've got one corner that's not flat, or there's something wrong with that reference face, you're not done at the joiner. It's not time to go to the planer. Other than that, you're going to set the thickness and run this thing through. Adjusting a planer can be challenging. Setting the knives is basically the same approach with a dial indicator, draw a couple lines on the cutter head and get them all to the same height. Once you have your knives to the same height, and you want them sticking out 1/16 of an inch or so, and by the same height, I mean about 3/1000 with respect to each other. The basic strategy is that you're next going to set the bed parallel to the knives. In practice, you can put a gauge, usually just a piece of wood, two pieces that are the same thickness in here, and there's a mechanism underneath in most planers for adjusting that bed side to side so that it's now parallel to the knives. You don't have a lot of adjustment, but 1/16 of an inch or so, you can correct any issues you may have. Then you're going to go through, and if you really want to tune up that planer, you're going to adjust all the mechanism. There are adjustments for feed rollers, infeed and outfeed. There's adjustments in most machines for the chip breaker and the pressure bar. The best way to approach this is to have a really detailed set of instructions and follow through them. It turns out this reference, Getting Peak Planer Performance by Robert Vaughn in Fine Woodworking, August 1994, is excellent. He walks through every step of setting up a typical planer and adjusting it and gives recommendations for it. And if you have a machine that needs adjustment, I would highly recommend getting this article. It's relatively easy to get back issues of Fine Woodworking because you can get them right off their website if you have to, or you can get the whole database and do it, and follow through it. He does an excellent job of explaining it. I'm not going to try to go through it here because it would take too long. But again, the basic strategy is to set up that cutter head first, then adjust the bed parallel, and then set relative heights of each of these elements so that they are gripping the board correctly and applying pressure to the board correctly before and after it's being cut, because the board's getting thinner as it goes through the machine. Planer operation. Again, this is a machine that should never be operated without all the guards in place. It's a machine where you need safety glasses, you need hearing protection, you need dust collection with a planer. For your own safety, because the planer produces a lot of dust to protect your lungs, but also for proper operation of the machine. A lot of planers can be operated without dust collection. You end up with sawdust everywhere. What can happen is the machine can actually ingest some of that sawdust or fail to spit it out. The sawdust can land on top of the board and go under the outfeed roller. And that leaves dents in your board. Okay? That's an issue if you're trying to build furniture and you're now leave your planer with all kinds of dents from all those chips that have been forced into the board. Again, no loose knots for exactly the same reason at the joiner. If for some reason you didn't get them out at the joiner and you've now discovered them, it's time to stop and cut that out. Use that board for something else, but don't run that loose knot through the planer. because you can do a lot of damage to your machine. It can cause a kickback. Planers can kick back if we're feeding in this way. The knives are going this way. There's a force. It can kick that board out. It's unusual, but it can. You should not overfeed a planer. It's very tempting, especially with a big machine like I have, to just shove those boards through as fast as you can. And you can overfeed them. And again, that's a bad idea. It's a good way to damage your machine and cost yourself a lot of money. So you want to stay within the capacity for thickness and for the rate. A lot of planers have an adjustment on the rate. And the truth is there's no reason to be spitting boards through there as fast as the machine can do it. If a board sticks, and this does happen, you get a board partway in, it's got a little thick spot in it or a thin spot that doesn't catch the outfeed roller and it sticks. The first thing to do is turn that machine off. Okay? Turn it off, reverse the feed. If you have a reverse on the feed, sometimes that'll bring it out. You're better off just turning it off, lower the table, and get the board out. Kickback. If you're feeding multiple boards into a planer, this is usually when you have kickback, because what will happen is you have one board that's a lot thicker than the other. So you have this feed roller that's now feeding two boards, and it's on springs. One side lifts up higher than the other. All of a sudden it releases this one that's thinner and it comes flying out. The machine isn't designed with a segmented in-feed roller, so it can handle different thickness boards. You shouldn't feed multiple boards. You should feed one board at a time, and that's why. The other thing to recognize is the feed systems are really powerful, and they're designed for pulling a board through whatever the width of the machine is and forcing it into that cutter head so it can be cut. And it can pinch you. It can pinch you between boards that are being drawn in. It can pinch you on the outfeed side as that board comes out and really get your fingers. So you want to be thinking about pinching and crushing hazards. Skewing a board, so you can take a board and we'll show you over there, you can turn it as it goes through. So now the cutter head is like this with respect to the board. On a straight knife machine, that can actually reduce tear out quite a bit. But beware, this is when you get pinched, okay? This is when you jam up a board because you feed it into something. You skew it too much, and now it gets caught as it goes in that machine. So it does present some hazards. Just be careful if you're going to skew a board as it goes through. They're straightforward, but there's a hazard for the in-feed and the out-feed for the operator. Okay, with that, let's just take a quick look at this planer. And okay, we can see the basic elements of the planer here. This is the table. It moves up and down. I've got it lowered down so we can see a little farther into the machine. I don't know if you can see it. We can see the table roller back here. We can see the in-feed roller. This machine has a segmented in-feed roller. It's a little bit difficult to see, but the in-feed roller is made up of 2-inch wide segments, each of which is independently sprung. And that allows it to feed multiple boards because there's always going to be a segment in contact with the board. The downside to this is that if you get one of these segments rolling right across the edge of the board, it can chew up the edge. It's the only downside I've found, and it's rarely an issue. It's hard to see any of the rest of it. If you'll notice, though, see how there's a cutout in the table where the roller is, for the table roller? That happens all the way across. There's one for the outfeed roller. If a board gets in there, when it's skewed, it'll get stuck right on that. And it can get stuck on the outfeed side there. Okay, if you are skewing a board a lot and you have your finger here and it gets pulled into that, you can get pinched very badly. Same kind of thing can happen on the outfeed side. So you want to be careful when you're feeding stuff in. Otherwise, the planer's pretty straightforward. Again, you don't want to overdo the depth of cut. So let's talk about table saws. Table saws are the core of any woodworking shop. They're probably the tool that we use the most, and they're the tool that's probably the most versatile for everything we do. We're just gonna do almost everything, almost every major shaping operation other than cutting curves, you're gonna do on a table saw. And fundamentally, a table saw is really just a couple of, I guess there are a couple of things that are critical about a table saw. The thing to know is table saws are really, really good at maintaining angles. Once you have a board that's straight and square, the table saw can keep things straight and square. So usually you're maintaining 90 degrees, either for a crosscut or for a rip. They're going to set width parallel to the edge the reference edge you've created on the joiner. You're going to crosscut your ends. You can make, dados and tenons and everything else on your table saw. So in order to do that, what you need is you need a really rigid table that is your reference surface. And you'll see every table saw, most of them are going to have a cast iron table or some kind of a heavy metal table. And that's the reference for the machine. And then you've got an arbor. Most table saws have a belt-driven arbor. We'll show you an example of one in a bit, and we'll show you one that doesn't. But most typical table saws have a belt-driven arbor, so you've got a motor hanging down, and then you've got a mechanism that takes that arbor and allows it to move up and down through the table surface to set height, and allows you to angle the blade to do angled cuts. And so you can see in the picture the arbor here, there's a belt going down to a motor, and we've got all this mechanism that's moving that arbor to the position where we want it for the table to work. Power does matter, how much horsepower you have in the motor. Big motors and small blades mean good deep cuts in hardwood. Okay, the bigger your blade, the more power you need in a motor. Ripping is where you're going to find that some saws can be underpowered. Typically not. Usually 1 to 2 horsepower is enough for a 10-inch saw. The other thing that gets really important with a table saw is effective dust collection. And it's a really big breaking point for table saw designs. A lot of contractor saws don't really have effective dust collection. They have an open base, and they're differentiated from a cabinet maker's saw because the cabinet saw will have an enclosed base. It's meant to be in a shop, not on a job site, and that enclosed base will enable effective dust collection because you can draw air down through the table surface, draw all the sawdust in here, and then suck it out with the dust collector. So that becomes really important. Those really are kind of the big distinguishing features between these, a cabinet saw and a contractor's saw. They're usually all about the same. Adjusting and tuning a table saw is really pretty straightforward. Essentially, what you want a couple of things that are really critical for the saw. The blade needs to be rotating true. And what I mean by that is no motion side to side for that blade. If you can grab that blade when the saw is off and wiggle it, that needs to be corrected. The source of that motion needs to be found. I'm not talking rotated, I mean wiggle side to side. That needs to be found. Usually it's not difficult to find. It needs to be corrected. There shouldn't be any noticeable slop side to side in the blade. If you have the blade rolling and you look at it and you can see it wandering side to side as it rolls, again, that needs to be corrected. That saw is not going to cut true. So how you mount the blade is usually the biggest source of problems in a table saw, and it's usually one of the easiest things to correct, and I'll show that in a minute. Every once in a while, the arbor mechanism and the mechanism that moves the arbor, it gets worn out. Most saws are pretty rugged machines, certainly a cabinet maker's saw is, and it's unusual for that mechanism to be damaged. They're relatively simple mechanisms. They can be disassembled, and usually they just need to be cleaned. Rarely do bearings have to be replaced, but occasionally, maybe once in a 40-year life of a table saw, would that need to be done. It is very important that the miter slots are parallel to the blade. If they're not, you can't make a straight crosscut. That's absolutely critical. And you can't change where the miter slots are in the table, right? Most table saws have some method for adjusting parallelism between the blade and the miter slots, usually by moving the entire table with respect to the blade, or by moving the actual place where the blade mechanism mounts to the table if it mounts to the table instead of the cabinet. Typically that's something the manufacturer would do when they build the machine. Usually the owner's manual will tell you how to do it. Here, this image from I believe this is from a Delta Unisaw manual, is pointing out that there are 4 bolts at the edge of the table that can be loosened, and you can rotate that whole table with respect to the blade. This is a once-in-a-decade adjustment on a table saw. But if those miter slots are not parallel to the blade, it is absolutely critical that you do it. The blade needs to be square to the table surface or at the angle you expect. That's a setup issue. A good square, again, back to that machinist square, really straightforward thing to do. If you are having a lot of difficulty with a saw maintaining square, you should, if you set it up and then take 3 cuts and it's no longer square, you should track down the source of that. You may have a clamp that's not, a locking mechanism that's not holding properly, needs to be cleaned usually, and you'll be ready to go. Throat plate. Most table saws have a throat plate. We'll talk about that one in a minute. It doesn't, but most do. It's important that that thing is flush to the table. If it's sticking up, your board's going to bind on it as it goes over. If it's sitting below the table, it's not going to really do its job well. Adjusting a throat plate is typically very easy. They usually have a few jack screws in them that let you adjust them. Zero clearance throat plates are wonderful. Sharp blades matter. It's probably one of the most common sources of an underperforming table saw is a blade that's not sharp. Most circular saw blades can be easily sharpened. You'd be surprised what can be repaired on a circular saw blade, and we'll talk about that. The other, waxing. I have a can of Johnson's paste wax around. I don't know where it is. But if you take a little Johnson's paste wax, especially on a cast iron table saw surface, and wax it once in a while, you'll be stunned at how much easier it is to feed boards across your table when you're ripping. It really makes a huge difference. The same is true for the joiner and the planer. It's worth waxing those machines, especially the joiner and the table saw. With that, let's talk about blade mounting, and we're going to do it right at the radial arm saw because we can see the mount there easily because it's sticking out. And then we'll go and we'll give Tom a call and look at his table saw. And then we'll talk about this one in blades. So this is a radial arm saw that I'm in the process of restoring, but it's a great place to show issues with mounting a blade. And everything you'll see here is, well, it's bigger than a lot of table saws. It is mechanically essentially the same, all the same issues with mounting a blade. Circular saws are going to have a left-handed nut, as I think everybody knows. And that's so that it tightens as the blade comes on. And then we've got essentially a big washer and a backing plate, and the blade sits between them and is clamped between them. And a couple of things are critical when you mount a blade onto a saw like this, and really on any table saw, any circular saw for that matter. The first thing that's critical is that the blade fit the arbor correctly. There really shouldn't be any significant up and down motion. It should just slide over that arbor and stay there. Okay? If the blade does not fit the arbor tightly, without any motion in there, you want to correct whatever the problem is on the arbor or correct the problem with the blade. The blade's not sized correctly for the arbor, or that arbor has a nick or a ding that needs to be taken care of. The next thing to notice is that on both the washer and the faceplate here, the center is relieved and it makes contact on this outside edge. That's what's doing the clamping. That's what's making contact with the blade. And if there is any dirt or debris or built up oil and sawdust and goo, which happens over decades of use, that is changing the height of that surface, and it's going to cause your blade to be a little tilted when it's mounted. The same is true if there's built up material in this area where that contact is made. Okay? So when you're mounting a blade, you just take your hand and feel it. Make sure that's clean, there's nothing sticking up. If you can feel it sticking up, you should clean it off. Same thing here. It's the easiest thing in the world to clean a surface like this. A little bit of Scotch-Brite, a little bit of WD-40 to loosen up the oil, rub it down with some Scotch-Brite, wipe it off with a paper towel. If you need to do anything more aggressive than Scotch-Brite, if you've got a big burr on this, somebody's whacked it with a hammer or something, you should consider whether you need to get a machinist involved or call the manufacturer and get a part. Okay? But very often if a blade isn't running true, it's not the bearings, it's not a bent arbor, it's dirt right here. That's what I wanted to point out. So this is a Delta Unisaw, and we thought we'd talk about it because it's a really nice example of a cabinet maker's saw. You have a nice cast iron tabletop. You can see your miter gauge slots here. It's got a throat plate, and I mentioned earlier that a lot of throat plates have adjustment screws. That's what these are. You can see the screws there. It allows you to level this throat plate flush with the table. I said the blade shouldn't move side to side, and if you just, the saw is off, it's unplugged. We can move it side to side and we don't have any slop. It'll rotate freely, as it should, but it's not going to wiggle. This saw has a splitter. That's what this is. It's an anti-kickback pawl. Goes in right here when you're ripping. Really nice accessory. A splitter is one of the nicer safety features you can put on a table saw for ripping. Splitter doesn't do anything for you cross-cutting. We'll talk about them a little bit more in a bit. But there are splitters. You can just glue a board in right here that sticks up. You can buy aftermarket things. You drill 2 holes in a wooden throat plate and stick them in, and you've got a splitter. This saw has a few other things. You can start to see the mechanism. If you look down inside and I turn this, you can see there's an arm over here that whole blade and arbor are moving up and down on. You can see it back here. It's carrying the arbor. The belt is right over there going down. We should be able to, we'll take a shot in a minute underneath to see the motor and things. You have a fence. The important thing with a table saw fence is not the brand name of the fence. It's that the fence is rigid and that it is easily adjusted so you can get it parallel to the blade, and that it's easily adjusted this way. If you're fighting with the fence all the time, it just consumes a lot of time and adds to frustration with a table saw. This miter gauge has a nice feature. Has this round washer at the end that goes into the T-slots so it doesn't fall off the table when it's not, when it's extended. Okay, that's a nice thing. It's not a necessary thing. If it's with the saw, it's great. It's not something you'd retrofit. Dado blades are a wonderful accessory on a 10-inch saw. Really add to a lot of the utility of the machine. Let's look underneath. If we can, let me get down here and open this up. So we can see the motor sitting here, and as I move this, you can start to see that that whole motor is being carried up and down as the blade goes up and down. So it's maintaining the tension on the arbor. It's essentially the whole saw is being moved, and if we were to adjust the angle, the whole saw is going to adjust with it. And this mechanism simply needs to move freely and lock rigidly when you're done. Okay? If it doesn't lock rigidly when you're done, that needs to be corrected. If it doesn't move freely, that needs to be corrected. And every once in a while, with an old saw, you will have to do that. But again, that's kind of a once in a lifetime cleaning and adjustment on a machine. If it is not, you can grab this and you get a lot of motion out of it. What you see here is fine. But if it's not staying true, then that needs to be corrected. I mentioned the bolts for adjusting the table with respect to the mechanism. All of this mechanism is mounted in the cabinet. If we loosen, there are 4 of them, this is one, and there's another one here. If we were to loosen those, we could move these whole table and the 2 miter gauge slots with respect to the blade and eventually get them parallel. Again, that's a once in a lifetime adjustment, but if it has to be done, it's critical to do it.